Hey there, everybody. Coming again from my kitchen island. And the next lab we would have done, which fits with Unit 11 on refraction and lenses, involves using a converging lens. And this is going to be very similar to the lab we did with the converging mirror. So I'm using converging lenses, which you might be able to tell a little bit thicker in the middle than in the end. Here's a large one, definitely thicker in the middle than in the end. And the first thing you'll notice with converging lenses is they magnify things. So if you have a regular magnifying glass at home, that is a converging lens. It's the same thing that we'd be using in the lab. And my magnifying glass simply magnifies the image. So if you have a magnifying glass at home, you might be able to reproduce this lab. Instead of using a little light bulb like I am, you can just use your phone with the home screen on with those images. It comes out pretty clear. I want you to notice again that my light bulb has the arrow pointing down to start with. We're going to be producing real images. So that means when we find the image, the arrow will be pointing up. This one is very similar to the mirror lab. The one difference is as light goes through, instead of bouncing off a mirror, it goes through a lens. And over here there will be some point where it all converges together. And then when those light rays converge together, we can find the real image. So I'm going to plug my light bulb in, turn my kitchen lights off, and there's my light bulb. So I just have it a certain distance away right now from the lens. This would be beyond twice the focal length. And over here, I can find a real image on the piece of paper. So at a certain spot, not there, not there, but right about there, I get a very focused real image. And again, it's not as clear on the video as it is here in my kitchen. It's a very clear image of that light bulb. If I move the light, which is my object, closer to the lens, then the image moves further away from the lens. And there's that nice focused image of the bulb. Not there, not there, but right there. See, a nice focused image. If I go to exactly twice the focal length, I'm going to get an image that's exactly the same height and exactly the same distance. So I'm getting closer. Notice there's my light, there's my object, and there's the nice focused image of the light bulb. So if I go to right around here, should be about twice the focal length, I'm going to get a light bulb that's just the same distance away and the same height as that object. That's at twice the focal length. It was the point we called the center of curvature with mirrors. Now if we move the light even closer, inside twice the focal length, so it's very close to the lens now, my image gets even bigger and moves farther away, so far away I can barely capture the whole thing on my piece of paper. But that's where the image is, quite a distance away compared to where the object is. And if the object goes to the exact focal length, then the light rays never converge, they go parallel to infinity. If I go inside the focal point, I'm going to get a virtual image, just like with a mirror. This will be easier to see with this light bulb off. But if I'm inside the focal length, and I look back through, I'm going to see a magnified image of that light bulb. You can see kind of the base of the bulb as opposed to where it is. So your magnifying glass is designed to have a relatively long focal length, so when you just hold it up in front of something, it magnifies it. But if you could produce something like this, which you might be able to do at home, just center your magnifying glass, maybe hold it with some tape, set up your phone somewhere over here with its home screen on, you'll be able to get a nice focused image somewhere over here on the other side on a piece of paper. something I think was worth trying at home, especially if you have one of these babies. So magnifying glass, just like a converging mirror, a converging lens, if you're inside the focal length, you get upright virtual images. And if you're beyond the focal length, you get upside down images. So there's my lamp in my living room, which is right side up. And if I go beyond the focal length, there my lamp is upside down, a real image. So just like with mirrors, all virtual images are upright and all real images are inverted. I hope this made sense. I encourage you to try this at home, and I hope all your class is going well as our class. Keep doing what you're doing, stay healthy, and look forward to seeing you guys at some point. Take care, everybody. Simon out.